Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing chemical properties of aldehyde and ketone. In that I have discussed reduction and oxidation. Also I have discussed tolerance test and failing test. Now I will continue chemical properties, that is reactions due to alpha hydrogen. But before coming to this, I want to solve one problem. This type of problem is asked in examination, particularly just in advanced engineering test. This type of question is asked. Then question I will tell you, and then I will explain it, because generally this type of question is asked. Question is long, but you should not fear from the question. You try to understand. Actually, what you have studied, this is based on that concept only, on that reaction only. Only you have to remember. You have to remember the, you can say, reactions. Then quickly you will solve it. Question is long, okay, but don't just fear from the question. Okay, I am telling you now question. An organic compound A with molecular formula C8H8O forms an orange red precipitate with 2,4-DNP reagent and gives yellow precipitate on heating with iodine in the presence of sodium hydroxide. It neither reduces tolerance or failing reagents, nor does it decolorize bromine water or Bayer's reagent. On drastic oxidation with chromic oxide, it gives a carboxylic acid B having molecular formula C7H6O2. Identify the compound A and B and explain the reaction involved. Question is long, but you can solve it easily. You have to understand the question. Again I am telling you question. Part by part I will tell you so that you can understand easily. An organic compound A, capital A, with molecular formula C8H8O. Compound A, its molecular formula is given C8H8O. This compound forms a orange-red precipitate with 2,4-DNP reagent. Correct? Means this compound C8H8O forms an orange-red precipitate with 2,4-DNP reagent. And again you listen, this compound only gives yellow precipitate on heating with iodine in the presence of sodium hydroxide. This same compound gives yellow precipitate on heating with iodine in the presence of sodium hydroxide. It neither reduces tolerance reagent or failing reagent, nor does it decolorize bromine water or Beer's reagent. Now again you listen. On drastic same compound means A. On drastic oxidation with chromic acid, it gives carboxylic acid B, capital B, having what is the carboxylic acid molecular formula? Then it is C7H6O2. It gives a carboxylic acid having molecular formula C7H6O2. Okay, this it gives carboxylic acid having molecular formula C7H6O2 on drastic oxidation with chromic acid. Means three reaction they have given, but exact structure you are not knowing, only chemical formula is given. First C8H8O compound A, it gives two product. First product with 2,4-DNP, it gives orange red precipitate it gives. That is the one product. You have to find out which product is this. What is the name of this product? And second, same C8H8O, it gives these things C7H6O2. This is the carboxylic acid. Then what is the name of this carboxylic acid? This is actually B, compound B. This you have to find out which carboxylic acid. And for their hint, they have given on these things. I told you on drastic condition it is giving this carboxylic acid, and for hint they have given that this compound, same compound C8H8O, it gives yellow precipitate on heating with iodine in presence of sodium hydroxide. This is given hint. Then now you think how will you come to know what is the name of the compound A and compound B. Then here two things you have to apply. First, that what is the possibility of the compound with molecular formula C8H8O? What will be the its a concept possible structure? You have to think C8H8O. You have to think what may be the structure, possible structure. And after that, second important point you have to think in this type of question that this what will be the product. Actually, some colored reaction already I have discussed. Then as for example 2,4-DNP reagent, this reaction is very limited. 2,4-DNP, that reaction is very limited. Okay, and this reaction to 2,4-dinitrophenylhydrazine, DNP means 2,4-dinitrophenylhydrazine. Last class I have discussed. Previous class I have discussed. Then you know what type of product it is giving already I have discussed. Only you have to remember. You have to remember that reaction. Okay. Then by color also, by color of the precipitate, you will get idea. Okay. Then color of the precipitate is very, very important to just know the what will be the reactant, means A in this case. And also this you have to think other what hint is given that this product this with reaction with sodium hydroxide this means this same compound when it reacts with iodine in the presence of sodium hydroxide, it will give yellow precipitate. Then last class only this also I have told you that these things oxidation of methyl ketone by haloform. Last class I discussed, correct? Then here these two reaction is sufficient to find out A and B. Then here C8H8O. Now this C8H8, it means that benzene ring will be there. Wherever more carbon will come, then there will be possibilities for, you can say, benzene ring. And actually you have to adjust like that, that some group should come. Then here oxygen is there, only one oxygen is there. Then possibility is that either it will be aldehyde. If one oxygen is there, then three possibilities are there. Either aldehyde or ketone or alcohol. Ether possibility is also there if one oxygen is there. But here I have to think in such a way that it should satisfy the molecular formula. C8H8O should satisfy. Then now you should always think for alcohol, ketone, aldehyde and ether. Four possibilities are there. Then you just you should think for all four, whether it is satisfying molecular formula or not. Then you will find that now if you think that benzene ring is there, and then you will think 6 carbon 6 hydrogen is there, but one 6 carbon 6 hydrogen, but one group has to attach there, then only 5 hydrogen will be there. Then only 3 hydrogen is remaining. Then 3 hydrogen remaining means carbon 6 carbon is over. Then here 8 carbon is there. Then 8 carbon is there. Then you have to think, see this in a proper way. Then benzene means 6 carbon. Then now 2 carbon you have to think over. 2 carbon, 3 hydrogen, 1 oxygen. Correct? Because 5 hydrogen is over. Then 8 hydrogen means 3 hydrogen is remaining. 2 carbon is remaining. And 1 oxygen is remaining. Then now what will be? You can think CH3. Then now CH3 means 1 carbon is over, 7 carbon is over, hydrogen is full, 8. And now if you think for the CO, then now fully it is satisfying C8H8O quickly. If it is satisfying quickly, then don't think for others. Okay, other it will not come. If you will think for other group, suppose CHO you are thinking with benzene, then you will get only 7 carbon you will get. Then it is not possible. If you think for the OH, phenol, then that is also not possible. It is not satisfying. Okay. Even for ether also you will think then CH3 or C4 you will think then also it is not possible. It will come 9 carbon. Correct? Alcohol also it is not possible. Phenol. because only six carbon is there. 6 carbon is there. Okay. That is also, you will think it will not possible. Then only this is possible. This is possible. Means C6H8O. This is actually ketone. Ketone is possible. Then other support is that means a 2,4-dinitrophenylhydrazine. When ketone means a methyl benzyl methyl ketone, one side benzene, other side methyl benzene ketone also you can tell. Then you remember when it reacts with 2,4-dinitrophenylhydrazine, then it gives a orange red precipitate. It gives orange red precipitate. Okay, this color you don't forget, precipitate color, and it forms a derivative 2,4-DNP derivative you will get. Okay, that is means here compound will be actually benzene. With that benzene COCH3 group will be attached. Okay, that actually when it will react with this 2,4-DNP, it will give 2,4-DNP derivative. Means now CO group will go, carbonyl group will go, and nitrogen will attached. Means this 2,4-dinitrophenylhydrazine is there. Then already I have discussed this reaction, that is this 2,4-dinitrophenylhydrazine in the place of Z, C double bond N, Z was there. Means ketone when it will react with this amine or its derivative like NH2Z, then it was giving C double bond NZ. Then on this Z, in the place of Z, you have to write 2,4-dinitrophenylhydrazine. Then you are getting 2,4-dinitrophenylhydrazone. Means carbon and nitrogen double bond will be there. Already I have discussed. And this derivative color is orange red. Then this is supporting that this compound will be that is the ketone. That compound will be ketone. Okay, that is this methyl benzene ketone. Now this is the one. For other you can say reaction, you can also understand that this compound gives when it will react with iodine, then it will give iodine in presence of NOH. It gives yellow precipitate. Then last class also I discussed that in case of iodine it gives yellow precipitate. Okay, NOx reaction I told you, X may be Cl, Bri. Then when it will react with iodine, then it will form iodoform. Iodoform reaction with sodium hypoiodide is, I told you, is used for the detection of CH3CO group. Okay, actually this iodoform color is yellow. Iodoform color is yellow when this ketone reacts with iodine. Then CH3CO group, if it is there, it will give yellow solid, gives yellow precipitate on hitting with iodine. Then this is also showing that according to the reaction, it is giving yellow solid CHI3. Its color is yellow, iodoform CHI3, and that it is supporting. And Other product will be the C6H5 COONA, correct? Then, but here yellow precipitate is CHI3. Then again it is supporting that compound is ketone only. Ketone methyl, this benzyl methyl ketone, that gives this iodoform yellow when it reacts with NOH. Then it is also supporting that compound A is ketone. Now, third reaction, that on drastic oxidation, it gives carboxylic acid. Then now you know that if ketone like this benzene methyl ketone, when you will oxidize it, then now CH3 will go and CO group will convert to COOH. COOH means benzoic acid. Okay, it will give you benzoic acid, benzene. In that one COH group will be there. CO group will be converted into carboxylic group. This will be benzoic acid. And now compound B will be benzoic. Whatever formula they have given, C7H6O2, it is satisfying 6 carbon of benzene and COOH, 1 carbon, that you can 7, and total hydrogen is 6. 5 of benzene, because 6th one is carbon is attached, only 5 hydrogen. Then COOH, that one H, that became 6 hydrogen. And now 2 oxygen is there because COOH is there. Then like that way you can solve many such type of problem. But here always they will give, I have seen, always they will give such type of a product that will be colored, or a special compound it will give, which you should remember always. Okay, they will not give which you are not knowing. Generally they will give such type of compound that will be generally colorful. Then you should know the name of the colorful compound and how it is coming, from which compound it is coming, and what is its condition. For all a special reaction, you should know the condition and product. Okay, always for a special reaction, because only such type of question they will give, where you will get some popular you can say reaction, and derivative will be colorful, correct? And sometimes process will be like such a way you will remember that things, correct? And this you can say this compound ketone will not react with tolerance or failing reagent. It neither reduces, actually you know that failing reagent and tolerance reagent oxidizing agent. Hence, because it is oxidizing agent, it can oxidize and it itself will reduce. Oxidizing agent gets reduced after oxidizing, correct? Remaining will be reduced state. Hence, here there is no rule. It is not reducing tolerance or failing reagent. That is also support. And also it does not dechlorize bromine water. Also it does not dechlorize bromine water. Ketone does not dechlorize. And these are the hints in the question to solve this type of problem. Okay. Then this I have told you this one problem, and same type of problem, similar type of problem, other problem may be asked in examination. Now I am coming to the new reaction, new properties. That is the reaction due to alpha hydrogen. reaction due to alpha hydrogen. Alpha hydrogen, you remember. Acidity of alpha hydrogen of aldehyde and ketone. First, you should understand this question is asked based on acidity of a alpha hydrogen of aldehyde and ketone. Okay. Then aldehyde CHO, correct? Then with this group, now CHO I told you. Then with CO group, that is a carbonyl group, next to this carbon CO, next to this carbon, if hydrogen is there, then that is called alpha hydrogen. CO is there. Now suppose with this CO, C, other carbon is there, and that carbon has hydrogen, at least one hydrogen, then that is called alpha hydrogen. Okay. Then now here what will happen? Suppose in general you understand CO group is there, with that carbon another carbon is there, and from second carbon H is there, that is alpha hydrogen. Then what will happen here, that this hydrogen, as we are talking about the acidity, hence this hydrogen should live as a H plus. Only then you can tell it is acidic, when it will go as a H plus in water, correct? Only then you can tell it is acidic. Then when suppose it goes as H plus, then carbon will have negative charge, because hydrogen is going as H plus, leaving its electron. Then carbon will be negative charge. Then that negative, now it can, because this negative carbon has 2 electron, 1 electron of hydrogen and 1 electron of itself only. Or you can tell CH bond, when CH bond breaks, then 2 electron will be there. That 2 electron is with carbon. Then now what will happen? These two electron can make, you can say, double bond. In the beginning it was only single bond, C and CH single bond was there. Now it can make double bond. Then what will happen? That when it will form double bond, then already C and carbon and oxygen was double bond. It was having double bond. That will become single bond. Means if carbon double bond is there, then carbon oxygen double bond will become single bond, and carbon will have positive charge and oxygen will become negative, correct? But here, as soon as carbon double bond will be there, then carbon and oxygen, that double bond will become single bond, and oxygen will be negatively charged, correct? Understood? That carbon, because this hydrogen, when hydrogen went, then carbon was having 2 electron. 2 electron you can tell, or you can tell negatively charged. Carbon was having negatively charged. And when CO will break, the oxygen will take negative, oxygen will become negative, and carbon will become positive. Then now this carbon is positive, and another carbon from which hydrogen gone, that is a negative. Then negative positive, they will make one bond. Hence carbon will be double bond, and carbon and oxygen double bond will become single bond, and O will have negative charge. Then these two structure, first structure and second structure, Means when carbon is making carbon-carbon single bond, that was the one structure when hydrogen gone, and when second structure when it is making double bond, then these two structures are reversible. These two structures are reversible. The acidity of alpha hydrogen, the acidity of alpha hydrogen atom of carbonyl group compounds is due to the strong electron withdrawing effect of carbonyl group and resonance stabilization of the conjugate base. Okay. Aldehyde and ketones undergo a number of reactions due to acidic nature of alpha hydrogen, and the acidity of alpha hydrogen atoms of carbonyl compounds, not only compounds, is due to the strong electron withdrawing effect of the carbonyl group and the resonance stabilization of the conjugate base. After releasing H plus, it is becoming a base. Base means always you think that carbon will have lone pair of electron. Okay, carbon must have a lone pair of electron or pair of electron. Correct? Then now on this basis I am telling you very, very important reaction, that is the aldol condensation. Aldol condensation. By name itself is there. ALD, OL means it is the two part. ALD means aldehyde, OL means alcohol. ALD plus OL means aldehyde plus alcohol. It is called aldol. When aldehyde will react with alcohol, the compound formed will be called aldol. This is very, very important reaction, and by name only it is clear that this is a reaction between aldehyde and alcohol. Okay. Then that product what you will get of aldehyde and alcohol, when both will react you will get product that will be called aldol. This reaction is called aldol. Now I am telling you little details. Aldehyde and ketones having at least one alpha hydrogen, at least. If you don't have alpha hydrogen, means second carbon with hydrogen, then this reaction is not possible. Two carbon must be there, one with CO, other never carbon, and that carbon at least must have hydrogen. Maybe actually a carbon has 4 valency, then 2 valency is attached. Other two valency may be attached with other group. Sometimes only one hydrogen may be available. Sometimes 2 hydrogen will be available, CH2, and fourth one will be other group. But here condition is that at least one alpha hydrogen must be there. Then aldehyde and ketones having at least one alpha hydrogen undergo a reaction in the presence of dilute alkali. You remember condition. This reaction takes place or undergo a reaction in the presence of dilute alkali as catalyst. Then what is the name of the product? What will be the name of product, or what is the name of product? Then name of the product is beta hydroxy aldehyde. Beta hydroxy. Hydroxy you are telling means you are talking about the OL. Then beta hydroxy aldehyde. Then here see oxygen, this alcohol and aldehyde, both groups you are taking the name. Product name is beta hydroxy aldehyde. That is called aldol. Also you can tell beta hydroxy ketones. Just like a beta hydroxy aldehyde. If you are taking aldehyde, then it will form beta hydroxyaldehyde. If you are taking ketone, then it will be called beta hydroxyketone. It is also called ketol, just like aldol. It is also called ketol if ketone is there. If you are using ketone, then it is called ketol, K-E-T. That is for ketone. And OL is common, ketol. Question is asked, you remember. Then product name is, if aldehyde, then beta hydroxyaldehyde, and if ketone, then beta hydroxyketones. Okay. Then here why you are using beta term? Then alpha you know. Same way, if with next to alpha carbon, that is called beta carbon. Okay, that is called beta carbon, means CO group. After that one carbon attached, that is alpha, and next to this beta. Correct? Again next to that gamma, after that del, like that way. Okay. Then this I told you, this reaction is known as, if aldehyde is there, then aldehyde and alcohol in the presence of dilute alkali as a catalyst form beta hydroxyaldehyde. But here I want to tell you that in this reaction, in aldol condition reaction, you will actually for the naming purpose I told you aldehyde plus alcohol, but in real practice you will take here two moles, or you can tell 2 molecules of aldehyde. You will take 2 molecules of aldehyde in the reaction. For the reaction you require 2 molecules of aldehyde. Okay, and that reaction they themselves will react. Okay, 2 molecules of aldehyde is there, then in the presence of dilute NOH it will form actually these things I am telling you stepwise. First it will form 3-hydroxybutanol, because here CH3CHO, suppose you are taking, I can say ethanol, this is called ethanol, CH3 one carbon, CHO, that is a second carbon, then that's why it is called ethanol. Al means aldehyde. Then total 4 carbons are there. If you are taking 2 molecule, then total 4 carbon is there. Then 4 carbon is there, and it is a CHO, then it means 4 carbon will be there, and total 8 hydrogen will be there total, including 2 molecules called CH3 CHO, then CH3 3H and CHO 1H, 4 hydrogen and 2 oxygen, means 2 carbon, 4 hydrogen, 2 oxygen. Correct? 2 carbon, 4 hydrogen, and this is a double you will do, then it will become double. In one molecule 2 carbon is there, and hydrogen is 4, and oxygen is only 1. But if it is 2 molecules, then all will be double. It will be doubled, means carbon will be 4, and hydrogen will be 8, and oxygen will be 2. Correct? Then actually here in this reaction 2 molecules will, they themselves will react. Correct? And due to their arrangement, you can tell, internal arrangement, when both CHO and CHO plus CHO, when both will react, then it will form 3-hydroxybutanol, ALL, that is called actually aldol. Here now you can see total number of carbon, then total number of carbon is 1 CH3. Actually compound is CH3, CH, CH2, CHO. And from the aldehyde side, if you count, then third carbon is, at third carbon OH is attached. Then now see, total carbon is now how many? Then it will be 1, 2, 3, 4 carbon. CH3, CHO. 2 carbon was there. Now it became 4 carbon, double. Hydrogen was 4. Now you can see how many hydrogen is there. Then CH3, 3 hydrogen. And CH, third carbon, OH is there. There 1 hydrogen is there. 4. After that CH2. Then 6. Correct? And so after that CHO 1 hydrogen is there and OH 1 hydrogen is there. Then total 8. Total 8 hydrogen. 8 hydrogen was there into ethanol. Total 8 was there. Now we are getting total 8. And oxygen was 2. Here CHO and OH. We are getting 2 oxygen. Then here alcohol group and aldehyde group both are present in this compound. That's why also you can understand like this way why it is called aldol, because here aldehyde and alcohol OH group both are attached. Okay, at third carbon OH group is attached. That's why it is called 3-hydroxy. Total 4 carbon is there. And in the end CHO is there. That's why including CHO carbon it is a butanol. 3-hydroxy butanol called aldol. Okay. Now here can say one more change is possible. Okay. From this aldol, what will happen that OH is there, and near that carbon OH attached to the carbon, that next to that carbon CH2 is there, then that H is close to OH, means third carbon OH is there and second carbon CH2 is there, means one H of second carbon and OH, it can interact and it will form water, and OH will go, OH and H both will go. Then when OH will go as a negative, then that carbon will become positive, and if H will go, then it will go as a H plus, then that carbon will become negative, then positive and negative, they will make a bond. Then that time there was a single bond, now it will become double bond. Then now in the next step you will get CH3, CH, double bond CH, and in the end CHO was there. Means now we can tell butene, but 2 enol you can tell also, because in the end CHO group is there. Then total carbon is 4, and at carbon number 2 double bond is there, 2 and 3, between 2 and 3 double bond is there. Then but 2 enol, and popularly is called aldol condensation product. Then here water is 1 molecule of water gone outside, okay, in the second product. From aldol to you got now from aldol you got but 2 enol, you got this. This is also another name of this compound is aldol condensation product. Then this reaction is very, very important, and this is actually called aldol condensation. Why the term condensation? Why you are using the word condensation? Then you are using condensation because 2 aldehyde is attaching. means becoming one. Two became one. That's why it is called condensation. And also you can say finally one H2O is going outside. Then because two aldehyde is attaching to itself, that's why you can tell it is condensing. Okay, becoming little small. H2O is also going outside. Then there is this type of reaction is called aldol condensation. Here you should know, actually here you have used only a small alkyl group. CH3 is a small alkyl group, correct? But always it is not necessary that group will be a small. It may be CH3, only one carbon is there in this alkyl group, but it is not possible that only one carbon will be there alkyl. Alkyl may be ethyl alcohol also, means 2 carbon, propyl also 3 carbon. All things are possible. And also it is possible that here you have taken 2 aldehyde you have taken, same aldehyde you have taken 2 times, but all that is also not necessary that both will be the same. Both will be the same, not necessary. Both may be different also. Both will be aldehyde, that is a main condition, but alkyl group may differ. Alkyl group may differ, means one aldehyde may be other alkyl group, in other molecule it may be other alkyl. Then there also process will be the same. Both aldehyde will attach, correct? But that time it will be called mixed aldol reaction. Okay. Then here by one example I want to clear it. Okay, this is also called actually aldol condensation. Then now I am telling about the mixed, or also called cross aldol condensation. Okay, then here this you understand, I am telling you condition you remember. Then here already I have told you in this reaction aldol condensation, the name aldol is derived from the name of the 2 functional groups, aldehyde and alcohol. In aldol condensation I am talking about. After that I will come to the mixed. Then in this product your aldehyde and alcohol both are present, that's why it is called, name has been given aldol. Okay, and also the aldol and ketol readily lose water to form alpha beta unsaturated carbonyl compounds. Unsaturated means what? It formed double bond. In next step. Then there alpha carbon is also taking part, beta carbon is also taking part. Okay, that's why it is called alpha beta unsaturated carbonyl compounds. Okay, alpha beta unsaturated carbonyl compounds, which are aldol condensation products, and the reaction is called aldol condensation. Though ketones gives ketol, ketone will give ketol, OL, ketol. Compounds containing keto and alcohol group, same reaction, but that time in the place of aldehyde you will take ketone. Then though ketones give ketols, ketone will give ketols, means compounds containing keto and alcohol. That time aldehyde and alcohol was there. Now in case of ketone you will get 2 group, keto group and alcohol group. That's why its name is given ketol. Just like aldol, here you will tell ketol. Okay. The general name aldol condensation still applies to the reaction of ketones due to their similarity with aldehyde. Both are called aldehyde only till date. Okay, till date the general name aldol condensation still applies to the reaction of ketones due to their similarity with aldehydes. Okay, then now I have told you about the reaction between aldehyde and also ketone and ketone. Now just I want to discuss cross aldol condensation. This you understand, it is very very important. Question is asked in advanced level. This question, cross aldol condensation. When aldol condensation is carried out between two different aldehydes and or ketones, it is called cross aldol condensation. Already I briefed you. If now see the condition, if both of them contains alpha hydrogen atoms, if both of them contain alpha hydrogen atoms, it gives a mixture of 4 products. We will get more products. Now I am telling you, if both of them contain alpha hydrogen atoms, means aldehyde and ketone. If both of them contain alpha hydrogen atom, it gives a mixture of 4 products. Okay, by example only you can understand. Okay, that is first example. You can tell that one aldehyde is ethanol and other aldehyde is propanol. Correct? Two molecule is required. One is ethanol and other is propanol. You have to not bother. Ethanol, propanol, that is only group. Reaction will be as it is. What was in aldol? Same way. Then here aldehyde, these things, acetaldehyde and propanaldehyde, you are taking as example in presence of NOH, dilute NOH, and you are heating, then you will get because now number of carbon will be what? CH3, CHO, 2 carbon, and here 3 carbon in propanol. Total 3 to 5. 5 carbons are there, 2 oxygens are there, and 4 plus 3, 7 to 9, 10. 10 hydrogen is there. Then it will give same type of product, means a double bond, final product I am telling you. It will give CH3, CH double bond, CHO, simple way. Because in one group, in one aldehyde, it was CH3, first aldehyde CH3, and second aldehyde CH3, CH2 was there. Correct? That will be due to the so you can say second. See, one you will get what I told you, butane 2 in al. One product you will get, that is due to aldehyde. Due to aldehyde, you will get butane 2 in al. Correct? And you are taken this also propanol aldehyde you have taken. Due to that, again you will get another product, but double bond will be there, and but only number of carbon will be more. Here you should understand that you have taken both aldehyde and acetaldehyde and propanaldehyde you have taken, but you are getting 4 product. Then you know that for the reaction, if suppose in the mixture both are present, ethanol and propanol both are present, but reaction will take place, what I discussed in the same way. There you require 2 molecules of aldehyde. Here also you require 2 molecules of aldehyde. Here also you require 2 moles of propanaldehyde, correct? Then you will get total 4 product you will get. Then one product you will get, that is a butane, BUT, but 2 in L, means same product what you got due to the acetaldehyde what I discussed, carbon-carbon double bond. But due to the ethanol again you will get all thing will be the same, CH double bond was there, correct? But here that group is long, na, CH3 CH2 will be there, CH3 CH2 will be there, because 2 molecule you have used for this, CH3 CH2 CHO, propanol 2 molecules, hence you will get CH3 CH2 and third carbon CH and 4 carbon CH, that between that it will be double bond, and only with second carbon will get CH3, and only from that carbon CHO is attached, means with first carbon means CHO from that I am telling, CHO is attached with alpha carbon, correct? And only from that carbon CH3 is there, then 2 valence is over, and that this carbon only is attached with neighboring carbon with double bond, then now see 4 valence is over, and that third carbon only 1 hydrogen will be there, CH, and again that is attached with ethyl group, correct? Then its name is 2-methyl pent, because methyl group is one methyl group is at the branch, 2-methyl pent due to the 5 that straight chain ring, 5 carbon is there, and at carbon number 2 methyl group is there, that's why 2-methyl pent, and at carbon number 2 double bond is there, and 2-methyl pent 2 ethanol, 2 in Al, 2 in means double bond, Al, 2-methyl pent 2 in Al. This you got from 2 molecules of propanol, and first product what you got, that is the butane 2 enol, that you got from 2 molecules of ethanol, okay? Then this 2 product I told you got, now 2 more product you will get only in the same reaction, that is due to the this what I discussed, this is due to the simple or self-aldol product. Now this product what I told you, that is the self-aldol product, they reacted they themselves, CH3 CHO aldehyde, acetaldehyde plus acetaldehyde, then you got first product, and when propanol aldehyde plus propanol aldehyde, then you got second product. Now I am talking to other product, that is actually crossed or mixed. What I am telling now, that is the crossed or mixed, because now both themselves will react in the place of 2 molecule, 1 molecule from acetaldehyde and 1 molecule from acetaldehyde, propanaldehyde. Then here you will get CH3 CH, again next carbon C double bond, with that CH3 will be there, correct? What I have discussed, that same way CH3 CH, second and third carbon double bond is there, and with second carbon methyl group is there, and only with second carbon CHO is attached, means carbon number 2 and 3 double bond is there out of 4, correct? And last carbon is CH3 means from the CHO that carbon is first, after that 1 carbon is there, alpha carbon, therefore from that CH3 is attached, after that second and third double bond is there, and with the third 4th carbon is attached, that is the CH3, means you can tell it is a methyl but 2 enol aldehyde. Here you are getting aldehyde and methyl group, okay? 2-methyl 2 BUT but 2 in Al, here Here you are getting, whenever double bond directly you are writing, then only aldehyde you have to write, because OH went as water, with H it formed water molecule and went. Hence when double bond you are mentioning, then CHO group only will be there. This is the third product. Fourth product will be little long, because 2 molecules propanol you have used. Then now you will get CH3, CH2, CH3. 3 carbon you have written now, and 3 means first carbon means CHO, after that alpha carbon you can tell. CHO is attached to the carbon, that is the alpha. Then that second carbon and third carbon double bond is there. Means CHO, after that CH, double bond CH, after that CH2 and then CH3. Total 1, 2, 3, 4, 5. 5 carbons are there, and carbon number 2 double bond is there. Hence you can tell pent 2 in al. Pent 2 in al. Then here this product is called cross aldol product, because you got through 2 different aldehyde. Alkyl group is different, that's why you got these 2 products. Then this is called cross aldol. Cross word you will use only when both are reacting with different alkyl group. Okay, this from 1 molecule of this you got when 1 molecule of ethanol and 1 molecule of propanol just reacted. 1 molecule of ethanol and 1 molecule of propanol. Correct? And same way ketones will also react. 1 ketone, 1 aldehyde, both can react. You can take that way also, and same also ketone, 2 ketone can, when 2 ketone can react. Okay, means you can say in benzene CHO is benzaldehyde, you can tell. Benzaldehyde, 2 benzaldehyde can react. Okay, 2 benzaldehyde can react, but it is not necessary that both way that alkyl group will differ. In one aldehyde is there and other ketone is there. Okay, means benzene, with benzene CHO is attached, CHO is attached, and other with benzene ketone is attached, means methyl benzyl ketone. One aldehyde, that is the benzaldehyde, other is ketone, means with phenyl group is attached with one side benzene, other side CH3, in the middle CO is there. Okay, means benzyl methyl ketone, you can tell. Then here aldehyde and ketone are reacting, means CHO is attached with benzene, then that is aldehyde, benzaldehyde, and ketone CH3CO, that is the other side benzene is attached, that is the ketone. Then if this both will react, then again reaction will be in the same way. It means both aldehyde and ketone will react itself, and it will form again carbon-carbon double bond. No difference in the reaction, same way. What is extra thing that will be left out? Carbon-carbon double bond, that is the CH. Because one side you have taken benzaldehyde, and that oxygen, and here methyl group is in ketone, that is benzyl methyl ketone. That methyl, that 2 hydrogen is there, CH3 is there. Then 2 hydrogen from this carbon and 1 oxygen from the first molecule, means from benzaldehyde, H2O, it will go outside. Then only CH will remain from the first molecule, means from aldehyde, only CH will remain, but it will be positive, carbon will be positive, and here H2 gone, this 2H gone, then only CH will remain, but it will be negative because H gone as positive. Then this negative and that positive carbon will join. Hence it will form, that is the CH double bond. And That what was attached, that will be there, means benzene ring will be attached. Benzaldehyde means benzene will be attached with C carbon, CH carbon, correct? CH carbon, because O gone, and there it is attached CH of the ketone, CH of the ketone, CO group is there, CO, that will be remaining. Hence you will get one benzene ring, after that CH, double bond CH, again CO, and then benzene ring. This is actually called benzyl acetophenone. Its name is benzyl acetophenone. This is the major product. Other name is 1,3, because it carbon number 1 and carbon number 3. Two phenyl group, first I am the name 1,3-diphenyl. 1,3-diphenyl prop, 2 in 1 on. 2 in, carbon number 2, oxygen, this double bond is, this is there, double bond is there. That's why it is a 2 in, and carbon number 1, CO group is there, that is a on, 1 on, 2 in, 1 on. Then carbon number 1 and carbon number 3. Carbon number 1, oxygen is there, that's why on, and carbon number 3, that is the these things, no, carbon number 1 and carbon number 3, phenyl group is there, 2 phenyl group. That's why name is 1,3-diphenyl. Carbon number 1 and carbon number 3, total 3 carbons are there. Then carbon number 1 and carbon number 3, phenyl group is there. In the middle, that is the 3 carbon is there, but in that one is CO, and other 2 are CH double bond. Hence name is 1,3-diphenyl prop. Prop is due to the propane, 2 in 1 on. Then this I have discussed reactions, and tomorrow I will discuss some other reactions are there, and use also I will discuss the use of aldehyde and ketone, plus some remaining reaction I will discuss in the next class. Thank you.